All right, so what we're going to do for these kinds of graphing problems is we are just making a table where we've picked some x's to find some y's. Since we don't have any other b values, and we don't have like x squared or ax squared plus bx plus c, we don't have any b, we don't have to work too hard to find our center. We're going to kind of mainly live in that good view of the center kind of region. That's meant to be a 2. From -2, -1, 0, 1, and 2. If we don't have a b, we're not going to have a super amount of shift here. So we can just go with this center view. Even when we do for the next kind of few ones that we're going to work with, we're going to kind of just live in the center area. So what we can do is we can substitute those in and just calculate out the values, not have to think too hard or work too hard with it. Just kind of cruise. So we're doing -2 squared minus 2, and we can type that into our calculator. We do -2 in parentheses squared minus 2. So we have a 2, -1 squared minus 2. And we'll type it in a calculator. Not you. -1 squared minus 2. And we get -1. 0 squared minus 2 gives us -2. 1 squared minus 2 gives us -1. And 2 squared minus 2 is +2. So we can type those in the calculator, or we can start to do some of those with mental math, however you want to do it. But what we're going to do is plot up those points. -2, +2. -1, -1. So down here. 0, -2, 1, -1, and 2, 2. So even if we don't remember much about our quadratics, we can still plug and chug to find our graph. Because it should look U-shaped. It should look like this. Okay, questions on the parabola stuff? Okie dokie. Because I'm going to put up one of those formal definitions for us, so it's going to have like a paragraph. This is, again, a screenshot from the textbook. It is called the location principle. The name itself is not particularly important. All it means is when we have a polynomial, if I have a point that is below my x-axis and I have a point above my axis, somewhere in between there is a solution. Somewhere in between there's a root, a 0. That's what this says. Is if I have a point above and I have a point below, somewhere in between them there's a root. That's all it is. So if we're looking at a list of values, if I have an x with a positive y here and an x with a negative y here, somewhere in between those two x's, there's a root. So if one of them's positive and one of them's negative, there's a root in between them. That's what this whole thing is saying. And I don't like the way that's worded, so I'm going to change that. I don't like that. That's all it is. So it's got this whole giant paragraph to say, well, if you have a positive root and a negative root in between them, there's at least one solution. And we're going to practice with this, and we're going to identify some solutions where they're not going to be nice, tidy values by filling in tables. So we are actually going to be making tables and graphs, and we're going to make 3 today. So I'm going to give you guys graphs. Shock, all shock. So we are going to do 3, so you're just going to get the whole book marking thing. And you aren't going to need a ton of space to write like below them, so you can probably leave them together, but if you want to cut them apart, as always, there's scissors in the boxes. But we're going to be working with 3 of these today, and we're going to do it with tables. So very similar to the T table that we made in the bell work, we're going to make tables with these things. And this one's going to be our first one. So I know I've just given you a whole bunch of things to do. So glue in your graphs and then write down this equation. And then once you get those things done, start working to fill in this table. We're just going to work on substituting things into the calculator. Actually, I should probably show you where that button is on the calculator. So maybe just hold on the filling in. So write our equation down of our x to the 4th minus 2x cubed minus x squared plus 1. And what we're going to do is we're going to substitute these values in for these 5 values I have in this table. I don't know why it's 5, not 6, but it's 5. No, it is 6. It's just an odd choice, but that's okay. So what we're going to do on these is we're going to take these values, these 5 being our kind of basic center view, and I've just tucked one on the end because it made my table too long. And we're going to substitute it in place of our x in all the places we see x. So we're going to start with -2, and we're going to do this in the calculator. And actually, I'm going to view keeper's history. There we go. Ooh, clear. Just so we can see where these buttons are. So I'm going to take my -2 to get the any exponent, not just squared. It's actually the button above the square. And it's got a little, looks like an up arrow without a stick on it. It's called a caret. So it's that up arrow there. That lets me put in my 4. Then I'm going to push the right button to get out of the exponent. -2 times -2. Again, to raise to that power, we're going to hit the up arrow that's just above the x squared to put in the 3. And then I'm going to push the right arrow again to get out of the exponent. Minus our -2 squared plus 1. And it takes all those buttons just to press it in once. And we get 29. So my x value at -2 is positive 29. So we're just going to use our calculators for that. So then let's do our -1, and it's the same thing, same equation. I'm going to clear this just because I really don't like. Can I make you change your space, please? I don't like where the clear button hits. That is worse. There we go. Put it there. So we're going to do our -1 to the 4th minus 2 times negative 1 to the third minus negative 1 squared plus 1. And we get 3. That's significantly more manageable. So when we substitute in negative 1, we get 3. You can absolutely type in the 0 into the calculator, or we can notice that 0 to the 4th is going to be 0. 2 times 0 cubed will be 0. X squared will be 0. And the only thing that's not 0 is this plus 1. So that one's going to be 1. And then we're going to keep on chugging down the table. And we are going to use our positive 1 next. And we are going to substitute it in to our calculator. 1 to the 4th. Hit the right arrow to get out of the exponent. Minus 2 times 1 to the third. Right arrow to get out of the exponent. Minus 1 squared plus 1. And we get negative 1. Two more of these for this one. So we're just typing them into the calculator. So let's do 2. Two to the 4th minus 2 times 2 to the third minus 2. That is not what I meant there. 2 squared plus 1. We have negative 3. One more of these. And we're going to do our positive 3. 3 to the 4th. Oh, that's not 2 to the 4th. That was just 3 times 4. 2 to the 4th minus 2 times 3 to the third minus 3 squared plus 1. We have positive 19. So we have a lot of really random values here. What we're going to do is plot them up as best we can onto our graph. And I know some of them are off the board. Like our negative 2, positive 29 is going to be way off the board somewhere. It's going to be way, way up. Negative 1, 3, 0, 1, 1, negative 1, 2, negative 3, and 3, positive 19. So again, way up there. When we are working with these polynomial functions and are trying to connect up our dots, start at one end and connect the dots from left to right. So I'm going to start on the left side at my blue off-page dot. Hi. Just 1 second. Gotta connect my dots. Oh, except I have it too far out anyway. Totally fine. Sweet. Yeah, you got like 7 minutes until it's end time anyway. It's all good. So we're gonna connect from our arrow, hit all 4 of my dots and back up to my arrow. So what we're asked to identify on is where our zeros are. So if we look at our table or if we look at our picture, how can we tell where the zeros are? Well, on the picture, so I get it blue to see, there are x-intercepts, right? When we're looking at our table, it's where they change from positive to negative or negative to positive. So our solutions, so I can spell right. Between 0 and 1. And between 2 and 3. That's where our roots are. So between 0 and 1 and between 2 and 3. So as far as we're going to go with our non-nice and tidy zeros, roots or solutions, we're just going to find them by graphing. And we're going to do that by plugging and chugging in. Now that is not the only thing we can find from a table, because we're also going to work with some of our extrema. We're going to name them as, maximums, minimums, all that kind of jazz. But we're going to look at zeros first. Our solutions, roots or zeros, are also our x-intercepts. And those happen either when our y value is 0 or when it changes from negative to positive. Or positive to negative. Okay? So I'm going to put up another little definition, and what that is just talking about our extrema again. That we're looking at the extrema where it changes directions. So we've got a relative minimum and a relative maximum on this little picture. Extrema are where it changes direction from where it turns. We don't really need the rest of this definition. It's not going to be a huge deal. What we're going to work with is we are going to work with another table. We're going to graph it. We're going to find our zeros. We're going to find approximate locations of extrema. And I'll show you how we word that. So this is our next equation. We've got x cubed plus x squared minus 5x minus 2. And we're going to do this exactly the way we did on the last one. We are just going to substitute these values in to the calculator and get our values. So I've given us from -3 to +3. That's going to give us a really good view of the middle and see what's happening. So we're going to take this over to the calculator. And we're going to have -3 to the 3rd. Remember our caret button right here, this little up arrow, this is how we get the any exponent. Then we have to hit the right arrow to get out of that exponent before we move on. Plus -3 squared minus 5 times -3 minus 2. Bless you. So we get -5. Same thing with our -2. Substitute it into the equation. And if you want to, you can use a little trick I showed you last time where you go up, up, enter. And then just go highlight every -3 and change it to a -2. There's actually less button presses, but barely. 4. I'm just going to retype it because I like to do that. So then we're going to do -1 to the 3rd plus -1 squared minus 5 times -1 minus 2. And we have +3. For our 0, you can absolutely type it in, or we can notice that 0 cubed is 0, 0 squared is 0, 5 times 0 is 0, and all we have left is our -2. Three more on this one. So we're going to substitute in our 1. 1 to the 3rd plus 1 squared minus 5 times 1 minus 2. And we have -5. Same thing with 2. 2 cubed plus 2 squared minus 5 times 2 minus 2. And we get 0. And then one more before we start plotting some points. I have 3 to the 3rd plus 3 squared, that's not squared, minus 5 times 3 minus 2. And we have 19. And we're going to plot our points. Thank you, sir. So we're going to go onto our graph. I have my x of -3, y of -5, which for me is right on the edge of my graph. I think I gave you guys a 6 by 6, so you should be fine. Then I have -2, 4, +4. So 1, 2, 3, 4, way up here. -1, 3, 0, -2, 1, -5, 2, 0, and 3, 19. Way off the board. And this looks like chaos. Start at one end and then connect the dots without skipping any. So I tend to go left to right because I am right-handed and it's easier for me to do so that way. If you like to go a different direction, that's totally fine. So I'm going to start on my leftmost dot and connect from my -3 to my -2 to my -1 to my 0 to my 1, to my 2, to my 3. No crisscross, no loop-de-loop. But this gives us a cubic graph. This is an x cubed. And what we're going to do is we are going to identify our zeros and our extrema. So our zeros are the ones we've done before. Zeros are where it crosses our x-axis. Where do we have zeros? Or roots or solutions or x-intercepts? So where it switches from positive to negative. So we have one solution between -3 and -2. We have another solution where it changes from positive to negative between -1 and 0. And we have one more solution here where it crosses our x-axis right here. We actually have it in our value. At x equal 2. We don't have to estimate this one. At x equals 2 is our third solution. So this has 3 real roots. Our last piece of this is to identify our extrema. So we have 2 extrema here. Take this bright green. Ooh, that does not show up at all. So let's go with red. So this one here, up at the top, is that a relative maximum, an absolute maximum, a relative minimum, or an absolute minimum? This one. Relative maximum. That is a relative max near, and we're just going to say what it's nearby, and it's near x equals -2. Because we don't know for sure if that is where it turns. Maybe it turns closer to the -3, maybe it turns somewhere near there. But on my picture, it looks like it's near -2. We have another extrema up here, which we'll do kind of a lilac situation. This guy way down here at the bottom. A relative min. And we're just going to say it's near x equals 1. We don't have the absolute locations. Unless we went in and kind of guessed and checked our way closer together until we found where they truly changed direction, or until we do pre-cal. We're not going to find the actual location of where they turn, because that takes some way harder math. But it lets us get a close enough, it lets us get an estimate on it. Okay? So let's see. We can do one more of these because it's substituting in and then plotting our points. They don't take super long. So here's our last one for the day. So it says use the location principle. That just means we're going to plot our points to figure out where our zeros are, sketch the graph, and find the graph, and identify our approximate locations of extrema. So we're going to substitute these in. So use our calculators. 6x cubed plus 2x squared minus 29x minus 14. And we're going to do everything from -3 to +3. So let's start with -3. I have 6 times -3 to the third plus 2 times -3 squared minus 29 times -3 minus 14. And we get -71. Holy cow. See if -2 is less gross. 6 times -2 to the third plus 2 times -2 squared minus 29 times -2. I don't know why it keeps thinking I hit 5 when I hit 2's. Minus 14. Seriously, it loves the 5's. +4. Same thing with the -1. 6 times -1 to the third plus 2 times -1 squared minus 29 times -1 minus 14. And we have -300. 30 cents, because I put -4. What the heck is going on there? I'm like, what the heck? Let me retype that, because that is a whole lot that we don't need to do. I'm like, that seems a little much. It's because on my iPad, the picture is super duper small, and it's very easy to kind of chunky finger it. I was apparently very reliably hitting the 4. There we go, +11. That makes way more sense. Our 0, this one's the one that you can kind of eyeball because 0 cubed is 0 and 6 times 0 is 0. 0 squared is 0 times 2 is 0. 0 times 29 is 0, and all we have left is -14. You can also type it into your calculator. Last couple, 6 times 1 to the third plus 2 times 1 squared minus 29 times 1 minus 14, -35. And we're going to do +2. Oop. We gotta make sure we get out of the exponent, because I just put a whole bunch of stuff in an exponent there. 6 times 2 cubed plus 2 times 2. Oh my gosh, calculator, can you stop losing your mind, please? Because it skipped my plus. Thank you. 2 squared minus 29 times 2. Oh my gosh, calculator. Stop being a jerk. 29 times 2 minus 14. There we go. -16. Last one is going to be our +3. I'm going to do it this way because clearly I am having a problem with the typing. We get +79. So when we have numbers that are off our graphs, your options are to either kind of estimate it or count by different numbers on your graphs. I know I gave you guys numbered graphs, which makes that really hard. But you can count by 5s, you can count by 10s. Or we can just go, well, negative 71 is going to be way down there.
I didn't want to ask anything else, but this is 10 minutes. So.
Yeah. -2, +4. You're welcome. -1, 11, which is going to be off our graph way up. 0, -14, which is off our graph down. 1, -35, which is again very low. 2, -16. And 3, 79. Holy cow, big old function and very little on our graph. So we're just going to kind of say, well, it's looking kind of like this. Boop. But what we're really looking at here is we're looking at our tables to see if we can figure out where our zeros are. That's really what we want to see. Using our table, where do we have zeros? Where do we have solutions? It's where it changes from positive to negative or negative to positive. So look at our y values. Where does it change from negative to positive? Between -3 and -2. Oh, not that one. Here. So what's going to be between -3 and -2? Where else does the sign change? So we're looking for where the sign changes. Between -1 and 0. And we have one more sign change here. Between 2 and 3. So our solutions, roots, zeros, x-intercepts, are in these areas. It's really hard to see on here, but we do still have two extrema. We have a relative minimum, where x is 1, and a relative maximum, where x is -1-ish. But finding the zeros in the table, that's really the one we were looking at today. That one's just really kind of grossly off the map. Okay, so that's what we're going to be working with. We're going to be working with graphing. We're going to be working with tables. I'm going to pass out the homework. We will have time to work on it tomorrow. I think we're only going to do 2 tomorrow. There's only 4 on the homework. So there's not tons of them on here. I give you lots of space because this has a lot of plug and chug in the calculator.